So, hi everybody, I'm Naziyah Mahmood, and it's lovely to be here today to be speaking as a stat warrior in chief. So to everybody watching on Facebook or here on Zoom, hello, and I'll just get straight into this. So long story short, I'm an astrophysicist and aerospace engineer by background, so meaning that a lot of my work and research has been into studying space, whether it's to do with planets and stars or also to do with rocket systems and how we can get to those stars and planets and such. I'm also an equalities expert for Scottish Engineering, and what that means is that I work to make sure that the engineering sector here in Scotland is as equal and inclusive for as many people as possible. So it doesn't matter about your gender, your colour, your age and such. We want to make sure that it's welcoming for everybody. I'm also a STEM ambassador, and what that means is I kind of go around different schools, colleges, universities, companies and such to tell people more about just how amazing science and engineering is. And for those of you who don't know what STEM stands for, it stands for science, technology, engineering and mathematics. So anything that can fall under those fields, and there's so many subjects that do, then you are a part of the STEM fields. And I'm also a bit of a Jill of all trades, which I can discuss a bit later if I've got some time at the end. But some of these include being a martial arts master, a website developer, model, author, poet, and a few other things. And the reason I mention a few of these is because some of these also involve me using data. So when we speak about data, we're talking about information that we are collecting that we can then use for doing something else. So I will be mentioning a little bit more about that just in a minute. So a brief history of me, and I'll try and make this as quick as possible so it's not too boring. So I used to be this 3-year-old, really chubby little kid running around telling everybody that I wanted to be a neurosurgeon, that I wanted to be a brain surgeon, because something about the brain always fascinated me. And I don't know what really got me into it, but I think it's because as a child, I just always was told that being a doctor is a great thing. And of course it is. But then something happened. During that journey, I went on through primary school and then on to high school. I found myself, of course, enjoying that part of science in terms of biology and such. But then in my 5th year of high school, I had the most insane physics teacher who basically taught me just how much I enjoyed physics. You know, I know it sounds really odd to some people because most people think that physics is just a boring subject or something, but it's so interesting. So it came to that point where I had to make the decision for when I go to university, do I do what my brain has always told me to do and apply for medicine so that I can study the brain? Or do I suddenly do what my heart is telling me and something that I'm passionate about? So you see, I'm a person that goes more with my instinct than my brain. So yeah, sorry brain. I went on to study physics with astrophysics and I never looked back because it helped me research the stars and planets and more. And then from there, I went on to do a further study called a postgraduate study in aerospace engineering because it helped me to find my way to the other planets and stars and more as well. So we're here today talking about data. So what do we all think about when we think about data? A lot of people think about codes, they think about binary, they think about information. And that's very true. But data can come in many forms and it can come from many different sources and used for many different things. So I have a question for you all. The me that you are seeing in your house right now, or wherever you're sitting, am I real? Because of course, on your screen, there I am. But I'm also sitting here in my bedroom, well, my living room actually, which is turned into something out of the Matrix. So what's happening is through my computer and through my camera, data is being sent up to a satellite system, which is then being broadcast again over onto your computers and onto your screens through the internet. So in a sense, what you're seeing is a data version of me on your screens. And a couple of projects that I've worked on when it comes to using data. I don't know if many of you have ever heard of the LHC or the Large Hadron Collider. If anyone has, please do leave a little comment in the side section if you can, if you're on Zoom or in Facebook. So basically, the LHC is the Large Hadron Collider, which is a part of CERN, which is a basically it's a large particle accelerator. And what that means is that there's this huge metal donut in Geneva, in Switzerland. And what they do there is that they take particles, and these particles are what you get inside of atoms. And they are shot at each other at such crazy high speed so that when these teeny tiny little particles collide, they give off crazy amounts of energy. And by studying that energy that comes off of them, that data that we're seeing in our computers, we're then able to understand more about the universe and the world. But then what I did was I took my studies further onto space. So I know I can't see anybody here, and usually a lot of these talks I would be giving face to face. But if wherever you're sitting, if you have ever heard of NASA, stick your hand right in the air. Like, you probably can't see mine because it's going off the screen. But put your hand right in the air if you've ever heard of NASA. So a lot of us have heard of NASA because of movies and because of articles that we've been reading and such. But did you know that here in Europe, we also have ESA, which is the European Space Agency, who do fantastic work on space missions that are to do with something called Earth observation, where we look at the planet to try and see different kinds of issues and study it better, whether it's to do with the weather or whether it's to do with earthquakes and such. You know, there's so much out there that you can do. And one of the first missions for ESA that I worked on was called ESMO, which was to do with taking a lander from the Earth and placing it on the moon. But then one of my main missions was called CryoSat-2. So CryoSat-2 is the ice mission for ESA. It's kind of like the Frozen of the Disney realm, where what the satellite does is that it calculates the difference of ice around the world. So you can get ice on the land, you can get ice on the sea, in the oceans, but what this does is it measures how it's melting over time so that we can then learn more about global warming. And obviously one of the parts of STATWARS here is tackling climate change. And global warming is basically one of the symptoms, it's one of the effects that we see from climate change taking place. And it's something we need to learn more about so that we can make the world a better place. So the way CryoSat-2 works, it kind of looks a little bit like a tent, like a very small house, and it is up in space about 700 kilometers. That is almost the distance between London and Switzerland. That's how far it is. It's really, really high up. And what it does is it shoots down these signals, these radio waves, which then hit the ice and bounce back up to it. And by being able to do that every single day, that satellite is able to make sure it's learning more about if ice in certain places is melting or if it's changing or not. And what it's found is that yes, it can melt, it is melting. And that's because of the world getting warmer and warmer. But obviously, we all know what happens to ice when it gets warmer, don't we? It begins to melt. So I ask all of you, I want you to kind of brainstorm this, think about it a little bit. What would happen on this Earth if the ice all melted? If all of the ice just suddenly melted, what would happen? Again, any kind of ideas you have, feel free to comment and such. But then as some of the things that we understand about it is when ice melts, of course, the sea levels rise. And that can cause flooding in some places. It can go over onto the land, cause flooding, so it can ruin homes, it can ruin crops and farms and such as well. And of course, that also affects the ecosystems within the water, so that so the animals living up on the shores and the sea animals as well, basically. So it has a knock-on effect. So this is something we really need to think about, and how can we tackle that? So a lot of you will have already been researching about climate change and the different kinds of things that are affecting it right now. And one of the ones we know a lot about is pollution in terms of litter. So we've been seeing images and articles about litter being scattered all over our oceans and seas, and it's affecting the people, it's affecting the animals that are inhabiting those areas. And we've all seen images of, unfortunately, turtles that are caught in plastic nets and such as well. So this is awful, and it needs to change. We need to start thinking about our own responsibilities that we have to make a cleaner, greener Earth. But one of the other things that also causes pollution is air pollution. So when we see lots of car fumes and lots of fumes coming off of factories and such, this causes this causes more CO2 emissions. So that's carbon dioxide that comes out of these chimneys, in a sense. And what that does is it has something called a greenhouse effect, which warms up the Earth, again leading to a warmer climate. And what happens when the temperature in some places becomes a lot more warm, obviously it can start fires. And again, we've been hearing a lot more about how over the last 5 to 10 years, these forest fires have been increasing in numbers, and that of course can wipe out entire regions within different countries. And it's heartbreaking, you know. And of course, with warmer weather, we also see drought. We see crops not growing, we see vegetation failing, and which also means can lead to food poverty, so people not having enough food in different places. So here we're seeing effects of climate change on the land, in the air, and on the water and the sea. But there's one climate that not a lot of people think about that is still technically of the Earth. And that is our space climate. That is what we have around the Earth. And if anyone's ever seen WALL-E, the Disney Pixar movie, you might remember scenes when you look at the Earth and it just looks like there's this ball of junk around the Earth. So unfortunately, we're not all too far from that, but you know, we do need to start working to make sure we're also picking up our litter and junk that's around the Earth right now. So this is called space junk. And this is caused by satellites colliding against one another and just being obliterated into tiny, tiny little pieces. So at any one time, so right now, we have over 2,666 satellites in orbit. And that's a lot of satellites, but we have even more satellites like that that are either not active right now, or they're failed, or they're breaking apart. And in space, the issue is that if you have something that's even the size of a 2-pence coin, because in space there's nothing to slow it down, and these objects are going at really, really, really fast speeds. So if that collides with another satellite, so even if this is a functioning satellite that's being used to monitor something, if that 2-pence coin size of junk collides with it, it can completely destroy it. And these satellite missions cost millions and millions of dollars and pounds. So not only, of course, it's a waste of money, but it's also then affecting the research being done, because many of these satellites are being used to help us learn more about climate change. So just like CryoSat-2, but then there's other ones that are watching out for things like forest fires. So it can tell us there's a fire about to start, and we can try and prevent it from happening. Ones that are looking into earthquakes and tsunamis and so much more. And of course, the way you're seeing me on your screens right now are through something called communication satellites. And all of these satellites use data, and this is how data can be so powerful in being able to make a difference in the world. So taking it back to space junk, there is something called debris mitigation. All that really means is space junk cleaning, really, in fancy words. This can be a really expensive thing to do, but what a lot of companies are beginning to do is that they're beginning to make missions, space missions, like ESA has with Clear Space One, where they're trying to find ways to get rid of this junk. And this is where all of you all come in, all of our students, this is where you come in, because the future of that is going to be in your hands, where you're able to come up with new ideas about how we can clean all this junk away from the Earth. So right now, there's many different studies happening where some people are thinking about using nets, some think about using harpoons, and again, other missions where they're using things like robotic arms to reach out and grab this junk. So there's many different ways that this can be done, but we need more ideas and more innovation happening, basically. So as we can see, data is actually used in so many fields. So, and one of those is in space. And this kind of data can be used to combat this climate change. And as we go forward, this is going to become more and more and more important for all of us to be a part of. Everybody, whether it's helping us to be more eco-friendly with our recycling, to learning all of this data that's coming from satellites, it's important we're all getting on board. So one of the things I always say is that if you're part of the STEM fields, whether that's science, technology, engineering, or mathematics, if you're a part of that field, you are working towards making a better tomorrow. You're working towards creating a better world for all. And if that's what your goal is, then that makes you a stat warrior. Thank you.
Thank you so much, Naziyah, for that brilliant presentation. I think like you said, then we'll wait for some questions to come through as well. But yeah, big thank you, because that was fantastic. And I really liked your background then that was coming through. I wish I could do that as well. It's fantastic. So we've got some questions that have come through already. The first one that I'd like to ask is, why did you enjoy, you were talking about growing up, why did you like the sciences so much? I know you spoke about one of your teachers that really inspired you, but kind of before that, why did you think you went towards the sciences?
I think for me, it's that a lot of that influence was there with my family. So I kind of grew up with my dad always talking about kind of maths and how great it can be and how interesting it can be, which was odd because when you're a kid, everybody hates math. Nobody wants to do algebra, and all these things. But when I was kind of growing up, I realized that how maths and technology and science can be applied to most things. So I love art, and I am an artist as well, so I do a lot of painting. And what I notice is, but even when I'm doing my sketches and I'm doing my painting and such, I'm using I'm using kind of scaling when I do that, and that in itself is mathematics as well, and that can be applied everywhere. And of course, going forward, I had that teacher who helped me realize this. So even when I had people around me, like friends and such, who used to say to me, "Oh, you're such a geek, you're such a nerd," I would take that as a compliment, because I'm like, I might be a geek and I might be a nerd, but it just means that I'm passionate about something. So that was always one of the great points of it.
We've got one here as well asking about, obviously we're doing STATWARS, thinking about the 3 things that children and themselves would change. Do you have anything that you would change, maybe 3 things that you would change at all that impact your daily life and have any impact at the moment?
Well, it's, of course, we can all sit here and say that we want to make massive change. But it all starts with all the small individual actions that we all take. So whether that's something as small as trying to recycle a little bit more, or trying to use tools or daily accessories that we normally do that are a little bit more eco-friendly, that is a small step. But when everybody does that collectively, all together, it adds up to a much bigger effect that can make a huge difference. So, for example, nowadays we've seen how a lot of companies and organizations, and even like when we go into like restaurants and such, they're moving away from using plastic straws, because we've seen the effect this can have on ocean life. And they're using reusable ones, or people are buying metal ones now and such. So something as small as that can make a massive difference. So I say start small. So one of the things I would say is start small at home, whether that's you using something that's reusable or recycling a little bit more. One of the other things I would say is spread awareness. A lot of people think that it's quite scary to maybe speak about this to others, to say, oh, maybe we should try using a different method of doing something. So whether this is in your classrooms, or whether this is in your schools, or within your friends groups and such, it's actually such a wonderful thing to say to each other. Let's do this together, motivate one another, inspire one another to do better. And if I had to say one more, then if you find yourself passionate about something, go into that field and see how you can then apply it to making a difference when it comes to climate change. So whether you want to go into space, as I did, or whether you want to become an accountant, or whether it's to do with law, all of these things, we all need each of them to be able to make a difference.
That gives some kind of really good advice as well, so thank you for that, Naziyah. Lucy's asking, what qualifications would you need to get into working with the Large Hadron Collider?
So the Large Hadron Collider, as we said earlier, it's a particle physics experiment, which means that it's to do with the study of atomic matter. And for that, usually what they look for is for somebody to have studied physics, because this is where you learn more about it, and maybe even or even if you have a background in chemistry. But one of the things I usually like to say to a lot of students when I've got talks is, transferable skills are such an important thing. So I've had people say to me, oh, to go into the space field, do I have to have physics, or do I have to be an aerospace engineer? And yet I've worked on projects where people working on it with me didn't even have an engineering background. They came from a law background. But it's because they were very good with problem solving. It's the skills more than it is the actual courses and such that can be really important. So if you can show that you are very good with problem solving, it's not as difficult as you think to get on board.
I know you spoke after that, you said you got into kind of working in space. What made you make that decision to then kind of go into that field?
So for me, because my studies had been to do with space, so my first degree, my undergraduate degree, my honours was physics with astrophysics, and I'd been learning about all the different aspects of it. And astrophysics is basically just extreme physics. It's the laws that we apply to something much, much larger, whereas particle physics is the complete and utter opposite when you talk about something like quantum physics, which is about the tiniest, tiniest of subatomic particles, but they need each other. So when I was studying everything, whether it's to do with black holes, whether it's to do with the stars, whether it's nebulas and galaxies and the universe, I found that incredibly, not just interesting, but there was something that was spiritually quite alluring to me. And then, of course, when I went on to do aerospace engineering, and my part of it was more the space engineering, we were working on designing our own missions from scratch. So everything from making the satellite to doing all the coding for it and such. And you have to work with a team to do this. And everybody has to be able to communicate with each other very, very well. And one of the things I really enjoyed about that was the teamwork. It is all down to teamwork. And I guess that's one of the things that pulled me more to it, not just what's happening out there, but what's happening here on the ground as well.
So we've got a question. I know you talked about all the interests and hobbies that you have as well. We've got a good question here asking, do you combine your STEM experience in your art and poetry?
Definitely. So as I mentioned a little bit earlier, when I'm creating any form of physical arts, whether these are paintings or sketches and such, there is an element of in there of kind of mathematical scaling. But one of the things I really do enjoy is when I write my poetry. So I'm a published author and I have a collection of poetry. And what I find there is that a lot of my poems, even though they're supposed to be, a lot of the time they're very reflective, they're very philosophical, but there's always that element of maths in there. If somebody understands the physics behind it, when they read these poems, they'll understand that I've put in a little Easter egg into their meaning that I've, without even realizing, I might be talking about something like waves and how they interact with one another, which is physics. Or other times I've spoken about, when I talk about the universe, a lot of it I will mention things like how stars are born and how they die and such. So there's always a combination of that. And one of my passions in life is martial arts, as I mentioned earlier, and I'm a specialist in sword work. So I'm licensed to teach and such, and I've been learning the martial arts since I was barely walking. And what's been happening there is, what do you usually get when you combine swords, space, and science? You get lightsabers. So one of the things that I've ended up doing now is making a lot of kind of online video clips that include lightsabers, where you can actually duel with them. Obviously, you have to be a practitioner and have the training to do so. But it's good fun because you're also applying the martial arts training to it, but there's also that really fun Star Wars part to it as well.
I was going to say that. I didn't want to jump in. I was going to say Star Wars, definitely. Have you ever looked at, I know you said you're an engineer and everything as well, building kind of your own, is that possible at all, building your own kind of lightsaber?
Definitely. So I actually have friends who build custom-made lightsabers, and a lot of these tend to be decorative ones. So you can't really use them, for dueling, but they make them from scratch. And a lot of the time, I've had discussions with some of my friends when they do this, where we sit and talk about the electronics on board. So of course, in the handles, they have small chips, electronic chips, where they not the kind of chips we eat, as cool as that would be, but basically those are used to help you light the saber up and then get those sound effects going and such. And one of the ones that I was actually sent over was by a company over in Brisbane, where they sent me a lightsaber to test out for them. And the way they tested how strong it was, because this one is actually made for dueling, is they dropped it onto concrete from 4 stories high, and the light still stayed on. It didn't have one scratch on it, nothing. So there's some companies who make them for dueling reasons, and you now have lightsaber dueling academies like Ludosport in London, and you've got them all over the world. So it's becoming a sport, like a real full-blown sport now. So you get decorative ones and you get duel-worthy ones as well. And in terms of making them, yes, I would love to. If I had the time, I would love to sit and make my own.
I bet growing up then you were very, very busy with obviously your martial arts and your love for STEP as well.
Definitely. So a lot of my time was always kind of between my studies and at the same time doing the things I really enjoyed doing. And one of the things I will mention is that, of course, a lot of these are very kind of male-dominated fields. So martial arts, and what I found with engineering was that there wasn't that many girls in it, especially when I was doing it before. So quite often I would be the only girl in my class, but that never deterred me, because knowledge in any form is for everybody. It doesn't matter whether you're a boy or a girl. It doesn't matter what age you are. It doesn't matter what color you are. Nothing. It's for everybody. So although it was a bit odd at the beginning, you find that strength within you to keep going, and the encouragement from the people around you. So I just loved combining everything.
Just touching that on that as well, Naziyah, do you think there's been kind of an increase over the last few years? Have you seen an increase in the data industry and engineering with female engineers and data professionals?
So what we've noticed is over the last couple of years, there has been a very small increase when it comes to certain parts of the STEM field. So like engineering, so whether that's things like construction or manufacturing and such. Right now in the UK, there is just slightly over 12% of the engineering workforce, not in studies, but in the working in industry, being women. And not long ago, this was 10%. Unfortunately, we're actually one of the worst in the whole of Europe for this, where many of those countries have actually over 50% of it being women, you know. And that's not to say that women have to make up over 50%, but we do have a lot more work to do in terms of getting more women into these fields. But we are getting there slowly, and we are seeing an increase, which is fantastic.
Yeah, I think that is brilliant, and hopefully it'll increase even further and more rapidly over the next few years. I know you were talking as well about flooding that's kind of happening around the world. We've got a question here saying, is this flooding kind of already happening a lot around the world?
So yes, we have seen, especially within areas, maybe within like Southeast Asia and the Far East, there has been a lot more flooding taking place, where we've seen entire villages being practically wiped out. We're seeing homes being destroyed. And over time, over the last, like if we took the last block of 20 years, we have seen that it's beginning to slowly increase. And for example, our weather systems are becoming a lot more turbulent. They're not as predictable as anymore. Which is one of the reasons we have satellite systems which are for meteorology and studying weather systems. So a lot of this has come down to this climate change that we're all here and talking about, because of the actions of people, of human beings over the last, well, all of history really. We've gotten to a point where we're reaching an extreme, and we need to make change as fast as we can, and that will take everybody to get on board with this. So like I said earlier, obviously, as an individual, we might not be able to wave a magic wand and make it all disappear. But if we could all start small and do something collectively as one massive group, it can make a huge difference. So one of the things we're seeing is, I mean, of course, with this pandemic that's happened, with this plague that's out there, you know, it's heartbreaking, because we're seeing how so many people are, you know, being affected by this all around the world. And, you know, we're having to stay in lockdown, everybody's staying indoors. And that's, you know, of course that's a shame. So this is not to justify that. But one of the things we have noticed is in certain areas of the world, the levels of air pollution, for example, have cleared up. Or, for example, the levels of litter and pollution in certain other areas are getting better. But that's not to say that we shouldn't be going out. Of course we could, but we just need to start being more conscious of the decisions we're making when we do go back again, so that we can have a cleaner world.
Yeah, and if anyone has got any more questions to ask, please send them in as well. We've got a few here that have come through. So I just would like to ask you, Naziyah. Well, let me just. Sorry, I think I've just lost the question there. Where has it gone? Oh yeah, so they're just asking here, what's the most interesting kind of project that you've worked on? Do you think? I know you've gone through a few in your presentation before, but what's the most interesting to you? Do you think?
That's a really difficult one, because I've done a lot of different projects and they've all been incredibly interesting. Oddly enough, I'd probably say one of my favorites wasn't even the ones where I worked in a space company. It was actually when I was at university working with my master's team. And we were there to design a space mission together. And we had to come up with this from scratch. And we were just students, you know, thinking, what can we do? What would we know? But then what we noticed was by sitting down and really discussing things together, we were able to brainstorm and come up with these crazy ideas that back then we thought, I mean, this wasn't even that long ago, but back then we thought, you know, it was, this is crazy, but maybe we can make it happen. And now, just a couple of years later, we're actually seeing those very things happen. So whether it's to do with using, so on a satellite system, you have something called a payload, and that is your main instrument. So for example, if there's a space mission and the point of that space mission is to take pictures of something, the payload would be a camera of some kind. Or if the main thing was for it to measure something, it would be a sensor of some kind. So we were designing a satellite system that used something called smart dust. And smart dust were these tiny little, almost like robots that get scattered over the surface of the moon. And back then, the idea of this happening was a bit crazy, but we're seeing these kind of things becoming more and more possible. So it's basically anything, any project that allows me to use my imagination is always one of my favorites.
Sorry, my mic just wasn't on then. Behind you, I think we can see two figures. Is this something that you're interested in as well? Have you made these at all, or did you buy them?
So long story short, and as I mentioned a bit earlier, I am a proud geek. So I have been, as you can probably see from the glowing cat ears on my head, I've been involved with a lot of, whether it's to do with anime, manga, gaming, conventions. This is for a long time, where I'd even organized large events, and I was the president of my university manga and anime society. So a lot of my childhood was growing up, especially with an older brother who was also into things like gaming and all of these wonderful things, which I still do till this day. So although you can't see it around me, my house is a bit of a waxworks museum where I've got figurines. Some of them, like these ones, are at least like about a foot to 2 feet high, but you've got ones that are much larger, and there's figurines all around my house, whether it's Lego structures or anything to do with comics and things. And again, it was that idea about imagination. It's something that allows you to take this idea in your head and make it into a real form. So, I mean, here we've got Bumblebee, which is a transformer, and you've got Predator. And of course, you know, people would say to you, what has this got to do with science? But it's what they represent, really. So it's to do with that kind of artistic expression behind them, as well as the fact that if you can make that, you're an architect of some kind.
So you're crossing over to both our STATWARS projects there, Naziyah, because we're doing climate change, but we've also got our film and TV projects. So perfect. We've got one question here asking about the space junk that you were on about as well in your presentation. Is it just satellites that is the debris, or is there anything else that it could be as well?
Well, the vast majority of it is made up of satellite pieces that have broken up. There could be debris or like almost like dust or particles from, say, asteroid collisions and such as well that can get pulled into that orbit around the Earth and kind of remain there. But the vast majority of that junk is made up of those, unfortunately, of those satellites. A lot of the time, so we have obviously we have the magnetic fields around the Earth, and these protect us from radiation coming from the sun and such. But what happens a lot of the time is when we do get some forms of foreign objects like small asteroids or meteorites and such coming through, a lot of the time we don't, here on Earth, don't see them because they burn up when they're coming through the atmosphere, and they basically turn into dust, so we can't even see them anymore. And that happens with space junk as well. When it's small enough, if it starts to get pulled back into the Earth's atmosphere from gravitational pull, it just burns up. And that's one of the strategies actually that a lot of companies want to use to get rid of some of that junk if possible. But for a lot of that junk that's still around the Earth, in that sphere almost, we're going to have to really think of new ways to come up with cleaning that. So as I mentioned earlier, there's some thinking about using nets, some harpoons and such. But any ideas, it would be amazing, especially for our younger generations, to hear about if they thought about novel ways. I mean, I've heard people talking about using lasers, and other people talking about deploying these kind of hot air balloon type vehicles to go up there and do like a cleaning mission, but still a lot of work to be done.
So we've just got two questions left, if that's okay, Naziyah. So the first one is, what is your favourite part of your job, would you say?
So My main current role, so I've taken a step aside at the moment, and I'm still doing research into the space side, and I research something called horizontal launch systems, which is to do with, rather than going straight upwards, how can we go sideways by attaching a rocket to something like a very large plane to get it to where we need to be to then lift off from there, because it can make a mission a lot cheaper if you do that. But aside from that, my main role at the moment is actually with Scottish Engineering, and I'm that equalities expert. And one of the things I really enjoy with that is I get to learn so much more about other organizations and companies and what they're doing to make science and engineering more appealing to everybody in the country. Of course, like I said before, there is a lot more work needed, but many of these companies are wanting to make this change. So just as we were talking about making change for climate change, there's also this kind of human rights aspect to it as well, where everybody should have that right to do these equal opportunities, basically. And when it comes to making space for, especially for more women in engineering, that's probably one of the things I'm very passionate about, well, especially right now at the moment.
Fantastic. And just the last one to end, a really nice question, I think, is there any tips or advice or anything that you've learned over the years that you would like to share with the participants listening today?
There's so many wonderful bits of advice and gems of wisdom that I've learned along the way. So I couldn't just choose one, but if I had to select just a couple, ever since I was small, my big sister, she was one of the biggest influences for me that I've had, and she was almost like a mum to me in a sense as well. And she used to say to me, if you don't ask, you don't get. And there's no harm in asking, because what's the worst that can happen? Somebody will say no. And if that happens, you just dust yourself up and keep going and work on another opportunity. So basically that means don't stop asking questions. If you're passionate about something and you want to do something, go for it. If it turns out that's not supposed to happen that way, you can find another way there, but don't give up. And one of the other things I speak about quite often, so as a STEM ambassador when I give these talks, is this idea of self-confidence. Nobody is born feeling super confident about themselves and believing in what they do in themselves. But it's important to at least value your worth, especially if we are living in a society that is telling you, this is what you can't do, this is what you can't do, you can only do this, this, or this. Knowing that you have worth and value, and that you have just as much right as anybody else to chase that dream that you've been chasing. Believe in that and have that form of self-confidence in yourself to keep going.
I think that's some incredible advice. And I just want to say a massive thank you to you, Naziyah, for doing this for us today and taking time out of your day to answer those questions. I hope you've enjoyed it.
Well, thank you for having me along. It's been wonderful. As I said, normally I would have these kind of sessions face to face, but knowing that if this has helped anyone even in the slightest, and I mean, that's definitely worth it.
Brilliant. I just want to say a big thank you to those who have sent their questions in as well, and those that have been listening today. I hope you've all been inspired to take on our STATWARS competition and use our resources on our website, statwarscompetition.com, to help you. And please join us for our upcoming interviews as well. I've left a link for a survey in the chat as well for those participants, if you could complete that. And again, thank you for everyone to join us. I think we'll end it there. So bye, everyone. Bye, Naziyah.